Hey everyone! In this talk, we're going to build concurrent React from scratch. My name is Six, and I'm happy to be at Byteconf React 2020. In fact, I've given a version of this talk before in London, so this is actually version 2 of the talk, hopefully bigger and better. So here's a list of things that we're actually going to cover. It's a lot. We're going to cover what React Fiber actually is. We're going to cover linked list traversal, how React renders and then commits. We're going to cover how to write our own useState hook. We're going to cover what a work loop is and why it's so important to React. We're going to cover the create root API, time slicing, and suspense. The last two are kind of marquee features of concurrent React. That's what you think of when you think about concurrent React, but really all of the React features that have come out have been a result of the React Fiber rewrite 4 years ago. So we're just seeing the implications of what that means today. So it's very powerful and it's very fundamental to understanding what React really is. Before we get too far, I do want to acknowledge the people who made it possible for me to give this talk. There's no way I could have figured this out on my own. The primary resource you should check out is Rodrigo Pombo's Didact, in which he wrote a series of articles explaining to you how to build your own React. This talk is essentially a simplified version of that project. And in terms of understanding what React Fiber really is, I'm indebted to Andrew Clark and Lynn Clark, and I'm going to share those resources in the chat. Okay, so we're going to start by explaining what a JSX element is. It's really just a plain old JavaScript object. It has a type and it has props. So if you try to put it in code, it kind of looks something like this. I simplified it a little bit, but that's an H1 with a hello world as child. And that's really all the data that you need to represent HTML in JavaScript, which is essentially what JSX really is. So now that we understand what a JSX element is, let's actually try to write it out and render it onto the screen.
We're going to start with an empty JavaScript file. I'm just using Webpack to import some CSS, so we have some nice animating background over here. And this is literally the only JavaScript that we're running. For example, here I can write a console log, and it logs out here with nice hot reloading if I ever need it. So it's a nice development workflow. So the first thing we want to do is think about how to render a text element. We're going to write it from absolute scratch. So for example, here I can define a text L. It's an object with a type of text element and a props, which is a node value, because that's how the DOM defines text element. I know it's a little weird. Everything else is value, but this is node value. I also need a container. So container, I know just from setting up the HTML that it is get element by ID root, and that's the ID I've assigned to it. And finally, I need to render it. I have pre-prepared a render function. So it's going to import from utils over here. I'll show you that in a minute. And then we'll type text L and container. And that will just give it the arguments that it needs to render it onto the DOM. So that's great. That's something showing up on screen. Let's actually have a look at the source of the render function. It's pretty light. It's only about 17 lines of code. And basically just says, for example, if the element type is text element, we'll create a text node using the JavaScript API. We'll add any props that we want, for example, like the node value. And then we'll recurse for all the children, but we're not really using that right now. And then we'll append child to that container that was supplied to us in the render function. So pretty simple. We don't really need React yet, right? It's still a little bit of a hassle to type this object every time. So it'll be nice to actually have a nice utility function for that. So of course we have that. We can create text element and that auto imports from utils as well. And let's have a look at utils and what the source of the create text element is. And it's just a nice simple function that returns the object that we were handwriting anyway. Of course, when we write HTML, most of the time we want to write HTML tags. So we need some way to represent HTML tags. So let's actually see what that looks like from an object basis, like a type of H1, for example, and then a props with an object as well with children, which is always an array, and then text L. So I've put text L as a child, immediate child of this H1 tag. And I can place that in my render function, and that should refresh nicely to an H1 of hello world. This is what we typically think of as an H1, is actually a combination of an element and a text element. So of course, writing this as an object is kind of ugly. Let's actually tighten that up a little bit. So let's actually use create element. That's going to take a type of H1. It's not going to have any other props, and it's going to have a child of text L. And that's going to show up exactly the same. Let's take a look at the source of create element. It's pretty similar to create text element, except it has a dynamic type. It spreads the props, and it has all these children, and some of them, if you're just supplying a string, it helps you create the text element inline. Of course, this is nice, but what's even better is if we could use JSX. So over in this project, fortunately, I've enabled Babel. Notice that these are the only dependencies. I have no other dependencies. And I have Babel preset React, which has the JSX transform. Instead of all these function calls, I can actually delete all of that and pretend that I'm writing HTML. And I can say hello world. This still isn't good enough because JSX transforms to react.create element. So we actually have to define an object, and we'll just call it React. We can call it other things, but then we'll have to change the pragma. We'll just call it react.create element, and then that should work fine. So here we have a pretty good representation of how it is to write JSX and render it to the DOM. We create the element, we write JSX, and then we add it to a container, and we append it to the DOM. And because the render method is recursive, like I pointed out earlier, we can actually swap this simple element for something a little bit more complex. So here I have an app with a bunch of children, just for illustration, and I can actually type JSX as the element in line over here, and that should render out this app. Okay, so we fully explored what JSX elements look like under the hood. They have a type and a props. In real life, they also have a key, and you can toggle any one of these, the type of props or key, to trigger a re-render of that element. So now we're going to go from elements to fibers. And let's actually look at the difference between elements and fibers. So React Fiber is actually a data structure that's a superset of the elements that we've explored so far. For example, if there's a matching DOM node, we're going to add a reference to that DOM node in the object itself. Then we're just going to add a bunch of properties that are basically links to other fibers around it. So for example, its immediate child, or its parent, or its sibling, or its alternate version of itself that's being worked on in progress. We'll talk about that one later. Finally, we're going to include an array of hooks that basically store the states and effects and refs and all the other good stuff that you're familiar with hooks, as well as an effect tag, which is a marker from the reconciliation process, telling us, hey, when you commit this to the DOM, there's actually some DOM nodes to be created or some DOM nodes to be updated in place, or you should just delete them altogether. So the effect tag helps us separate rendering and committing. If you put all these concepts into a plain old JavaScript object, it will kind of look like this. It's got all the element stuff that you're familiar with. Then it's got all that linked list stuff to other fibers neighboring around it. Then it's got hooks and it's got an effect tag. So now we know what fiber is. Let's actually remind ourselves of why we want to use it. So currently we're rendering this app, right? And the way that we render this app is a pretty simplistic process of recursive render and commit. So here we start at the root, right? And then we head to the div, we'll render that, and then we'll commit it to the DOM. We'll head to H1, we'll render that, commit it to the DOM. And at any point during this process, a user can come along and see a half-committed DOM state, and this is inconsistent with the rest of the app, which hasn't been completed yet. So the solution to this is to render everything first and then commit. So here, we'll do the same thing that we did before we started the top level, but now we don't commit to the DOM. We'll actually just perform that rendering work. So here, we'll just call it perform unit of work, and then we'll proceed to the next child without committing to the DOM. So we're doing all these changes only on the fiber data structure. So we'll go to the child, then we'll go to its sibling, and meanwhile, if any user comes along, we haven't committed to the DOM yet, so it's still good. It still looks like the old version. And all this changes and diffing is only happening in the background on the virtual DOM. Then we'll head to our child again, and then we'll head to its sibling. And when we've run out of children or sibling or aunts and uncles, then we can recurse all the way back up to the root. Now that we know there's no more reconciliation work to be done, we can actually commit everything to the DOM, which is in contrast to the commonly held belief that we use virtual DOM because committing to the DOM is expensive. It's actually reconciliation and rendering that is expensive. If you want to learn more about the fiber traversal algorithm, head to React issue 7942, where Sebastian actually listed all these in greater detail. But for now, let's try to swap our implementation over to take advantage of rendering and then committing. Now this render is a little bit too simplistic. It just kind of goes through and renders each element in turn straight onto the DOM, and that affords us no opportunity to diff the DOM. So what we actually need to do is start to create a virtual DOM structure using React Fiber as our data structure. So for example, I'm going to introduce the concept of a work in progress root fiber, and we'll just call it WIP root for now. And we're going to start to populate this in order to replace our render method over here. So the work in progress root fiber is an object. It typically has a type, but at the root, we don't really care about a type. It has a DOM equivalent. So here, our DOM equivalent is the container. It has props. Here, we're just going to hardcode the props to have children of app, for example, which is exactly what we're doing up there. And then it has other optional stuff. So for example, it has links to other fibers that its siblings that our render traversal algorithm can pick up. So for example, it has a child fiber, it has a parent fiber, it has a sibling fiber, and what we're eventually going to get to is that it has an alternate fiber, an alternate version of itself, where that's the one that's rendering virtually, and then we'll swap it out. But for now, we don't need any of this, so we'll just keep it simple and call it the work in progress root. Okay, so what is work? We actually have a good definition of work in this context. Work is basically the work involved in rendering each of these elements individually. Basically, what we want to do is have an algorithm that traverses down this tree structure, does all the processing and render work, and then traverses all the way back up. And only once all of it's done, then we commit it to the DOM. Well, so we'll define a pointer called the next unit of work, and we'll set it initially equals to the work in progress root. So we start at the root, right? And basically what we need is a method that just processes the top level div and then returns the next unit of work. And we'll take that pointer and then we'll process the next child, and then it will return the next unit of work, which is the UL. Take that pointer, process the next child, and return the next LI. So that's the rough traversal algorithm that we're going to follow. So instead of a simple paradigm of rendering an element straight all the way down and directly onto the DOM, what we want to do over in the fiber section over here is that we want to be able to say, okay, we'll start with the next unit of work in the work in progress root. Then we'll perform the next unit of work. And we'll get back a reference to the next unit of work to be done, which is starting from the top and going down all the way. And while this next unit of work exists, we'll just keep doing it. And only after we're done doing all of that, then we'll commit that work to the DOM. And the thing that we're going to try to commit is the work in progress root child, which is the first element, which happens to be a div that precedes all of this stuff. We're actually rendering 2 copies of this app over here because we have a simple render and then we have the fiber render. So we don't really need the simple render anymore. I'm just going to get rid of that, as well as get rid of that from the imports. You notice in writing that code, we actually imported 2 more functions, perform unit of work and commit work. So let's actually take a quick look at their implementations. So this is what happens when we actually perform a unit of work. We branch on whether it's a function component, so we can just call it, if a function component's type is just its function, or it's a DOM node, so we just call the create DOM utility that I have defined below. Both of these paths end with reconcile children, which is a simple function that turns elements into fibers, as well as diffs fibers against fibers, and generates an effect tag. So either something has been updated, something has been created, or something has been deleted. When we're done with the rendering work, it's time to return the next unit of work. So either if there's a child, we'll return the next child, or if we have a sibling, we'll return the next sibling to do work on, or we'll recurse up to the parents and let our parents take care of their own siblings, our aunts and uncles. So that's performing the unit of work. Let's actually look at what happens when we try to commit that work. We're basically going through all the fibers and saying, all right, reconcile children has placed an effect tag on the stuff that needs to be updated. Let's go through and say like, if something has been placed, for example, like a new DOM node has been created, we're going to append child. If an update has been tagged, then we're going to update that existing child in place. So we're not deleting it and then recreating it. And if something has been deleted, then we'll also delete it. So here are all the helper functions available. And this whole utils folder, that's it. That's all the utils that we're going to need. It's only 177 lines long. So that's not too bad for the backbone of our new framework. So now that we've understood what perform unit of work and commit work do, and we have a concept of what rendering is and how we do all the render work, and then we commit it to the DOM, let's actually wrap this up into a nice render function that we can use. The API that we want is the same that we had before, which is basically render an app into a container. So let's define that render function. We'll call function render. It's going to take in an element and a container. I'm going to prepend it with an underscore so we don't conflict with that real container for now. Then we're going to take everything that we've just done and we're just going to cut and paste it inside of that function. So now we have a nice abstraction so that when we just call render L container, that should show up on the screen. We actually need all these declaration of pointers to be at the top of the module so that we can actually reference them. So let's take that and paste it up in here. And then we should get back our original methods. The difference of what we've just done is refactored our render function from a simple recursive render into something that is fiber aware, that renders all the work and then it commits only the differences. Now, of course, to enable concurrent React, we actually don't use this simple render API anymore. We actually have something that looks a little bit more like this, create root container dot render on an app. And this enables other methods of rendering, like, for example, blocking rendering. So let's actually refactor this API. It's pretty simple. We're going to define a function of create root, and it's going to take that container, same as always, but it's going to return an object with a render method that takes that element that we had before. So now we'll just take the contents of this render function, cut it out, and we'll paste it in here. And that should work fine for the create root. So now if we delete our old render method and call the create root function, it's going to work the exact same way and show up. It's just a refactoring of this API so that we can offer other render APIs as well. Awesome. We now know how to implement the create root API, but inside of the create root function, we only render things once from top to bottom, and then never again. We commit the work and then we're done. So essentially we need a way to loop through and re-render until the end of time. So that's what we're going to write next, which is the work loop. It's basically an infinite loop that doesn't hang your computer, which is very nice. The reason it doesn't hang your computer is because we're cooperatively scheduling our resources between the browser and our JavaScript. However, a simple work loop isn't enough. Because rendering is expensive, for a large DOM tree, you might actually choke up the browser while rendering your entire thing before committing to the DOM. You want to actually be able to pause and resume rendering. So that led to the idea of time slicing, and that's actually what we're also going to look into next. The differences between synchronous rendering, which is what React has today, and time slice rendering, which is what concurrent React has, is pretty dramatic. Here's a screenshot of a talk of Andrew Clark. This shows the differences between how React works in synchronous mode and as well as async mode, which we now call concurrent mode. In concurrent mode, our rendering yields back to the browser every 16 milliseconds so that we're always able to receive browser events. So this makes our apps feel a lot more responsive to user interaction. This is a major source of jank in React apps today. The benefits of time slicing aren't merely theoretical. I encourage everyone to try out the Sierpinski triangle demo and use the browser dev tools to verify this for yourself. Here we've got two examples. One uses the stack reconciler, the old synchronous reconciler, and the other uses the fiber reconciler, which is the new proposed reconciler. We can open up the stack demo, and we can see that the updates are kind of janky. They kind of update bit by bit. And even worse still, the circles are supposed to respond to my interaction. Like when I hover over them, they're supposed to just turn yellow, but they just take a long while and they kind of trail far behind where I am. If you open up the performance tab and you hit record on this, you can see large chunks of rendering work spreading out over hundreds of milliseconds. Let's take a look at the equivalent for the fiber example. So over in the fiber demo, you immediately see that the rendering is much smoother. And when I hover over these circles, there's very little delay. So that's very positive. Let's actually look at the performance tab and also do the same process of recording a little bit. And when we look at the performance tab, we can see a lot more choppy graphs, which means that the rendering process is yielding back to the browser, which enables for all this rendering and user interaction to work smoothly. So the benefits of time slicing is real and is immediate the moment we enable create root in concurrent React. For more details, you can check out Brandon Dale's benchmarking of this in this Twitter thread, which I'm going to paste in the chat. The main mental model that you should have in your head is that when we combine time slicing with a work loop, we're basically saying that we render until we run out of time, and then we'll pause and yield back to the browser, and then we'll resume again with the work loop, and then we'll render until we're done, and then we can commit all the way at the end. So let's try to implement that in our app, and along the way, because we want to see something update live on our screen, we're also going to implement a useState hook. So now we want to implement a work loop, and a work loop is kind of like a function that just calls itself again and again, similarly to a game loop, if you've done any game programming, which I haven't, but that's apparently what it's like. You might typically run a work loop with something like set timeout. So we can call work loop from within the work loop, and we can set timeout to once a second. And we can call that same work loop from outside of the work loop, so it can just keep running itself. And let's actually see that pop up in our console over here, because it's fun to watch. So here, every second, it's just going to pop up a new high. Great. So now basically what we're going to do is we're going to take out the rendering work from the create root function. I'm just going to cut this next unit of work stuff out. And we're just going to keep doing this every single work loop, right? We're just going to say, if there's a next unit of work, then we'll perform all that unit of work. And then once we're done, we'll set a timer for the next thing, and every second we'll start reconciling these changes. So instead of setting a work loop, we're actually going to use a request idle callback API. The reason that we want this is because request idle callback gives us an idle deadline, and we can call the idle deadline.timeRemaining function to give us a timestamp of how much time we have left in the current rendering frame. So this lets us time slice very well. So we'll take a deadline argument from request idle callback, and we'll try to calculate whether we should yield back to the browser or we should continue our work. So we'll say something like let should yield. By default, we'll say it's false, but we'll basically calculate should yield whether deadline.timeRemaining is less than 1. And if should yield is false, then we should continue doing our work over here. If should yield is true, then we should pause what we're doing and yield back by just calling request idle callback again. We should also not commit our half done work. So basically we should check whether there's still work to be done, like say next unit of work over here. And we'll still a commit work function inside of a check for whether there's a next unit of work. So in case we've paused our work to yield back to the browser, we don't accidentally commit our half reconciled work and undo everything that we just did. All right, I really want to see some dynamic stuff on screen. So we're going to start implementing a hook. So the first thing we want to do is implement a hook index. So all hooks are just positions in an hook array. And we want to modify our fiber data structure to have the concept of a hook array. So over here in our creation of the work in progress root, we can say something like hooks is an empty array, as well as the alternate version of our fiber, which we're going to also start to want to need, also should have hooks. So now we created the concept of an alternate fiber. Every fiber has its alternate, and we'll do our changes onto the alternate version before swapping over to committing to the DOM. This is important for us implementing useState. So here we're going to implement useState. So we'll declare a function useState. It's going to take an initial value, and that's about it. Now hooks are a bit unusual in that they're basically functions with some memory. And the way that we achieve that is you're basically pulling the old state based on the alternate version of the fiber that we're currently working on. So I've pre-written a bunch of that code so that we don't have to write it manually out. But let's actually kind of go through that. So essentially what we're going to say is that the old hook is actually picked off the work in progress root fibers alternate. And we're cheating a little bit by storing all the hooks on that single fiber. Ideally, every single fiber has its own list of hooks. Here, we're just co-locating everything onto the same fiber. And we're using the hook index to that specific hook that we want. And once we're done with that index, we'll increment it by 1 for the next hook. Then we'll look at that hook and we'll check if it has some pending state. And remember, this pending state could be null or undefined, so we can't really use falsiness as an indicator. So we actually have to use a symbol for none, and the symbol is and that symbol is not going to match anything. So we can actually just safely check this. And we're likely to use this between calls. So we actually need to elevate this none symbol to the top level so that we don't redeclare symbols. Otherwise they're not equal to each other. And the last thing that we need is the old state. So we'll just look inside of the old hook. If there's state in there, we'll take that state. And if not, we'll take the initial value that was given by the use state. So finally, our new hook that has been derived from all this data has a value of state. If there's a pending state, we'll take the old hook's pending state, which means that there was an update called by, for example, calling set state. If not, we'll just take the old state that was there before. And then we'll just say that the pending state of this is none for now, which is the same symbol that we used earlier. So with this done, we can actually write the remainder of use state, which is the interesting stuff. So for example, we can write the set state function, which takes a new state, which you give it, right? And it just appends it on the pending state of the current hook that we're operating in. So we're using closure to retain a reference to this hook. So even regardless of what fiber we're on, we can actually just directly append onto this hook, which is a very nice and convenient way to do this. Then we'll also need to schedule a re-render. And this basically says, okay, we actually now have a new unit of work to do. Let's go through and reconcile all the roots again with this new state. We haven't implemented this yet, but we'll get there once we're done with this hook. We also need to append the newly created hook to the work in progress roots hook array so that we can actually pull it off in the next run of this. And then finally, we can return that API of hook.state, which is that state that we just calculated, as well as setState, which is that function that people can call to set the state of the hook. So now we're actually implementing something that's dynamic, that actually says we're going to do all the state modification on one root, and then we'll reconcile it, and then we'll swap the roots over. So now we're actually forced to implement a current root instead of just a single root. So we'll say current root over here, and this is just a pointer. And inside of the work loop, we're going to assign to that current root, and we'll say after we committed our work, we'll assign a work in progress root fiber to the current root, like we swapped that fiber over. We're going to set our work in progress root to null because we are done with it. And we can say our hook index is 0. So we restart the index from 0 so that we can increment it all the way. Now, because we set the work in progress root to null, we also need to set a safeguard here, because otherwise we'll try to access the child of something that doesn't exist. So we'll just say if work in progress root is truthy, then we'll allow this committing of work to proceed. So now we've implemented a nice swap of we'll do all the work on a work in progress root, and then we'll swap over to the current root, and then we'll nuke the existing work in progress root. But we haven't implemented this schedule re-render function. So let's actually see what that looks like over here. So with the schedule re-render function, we're basically saying we want to take all the properties of the current root and clone it onto the new work in progress root, which we're manually going to set. And then we're going to set that work in progress root to be the next unit of work. So when the work loop picks up its next unit of work again, it says, oh, I have something there to do. I'm going to start at a work in progress root and just continue all the way down, just like we did before. Okay, so that was a lot of work to implement state, but now let's actually see this in action. I'm going to fold all the code levels, open up our app again, and try to implement a simple useState function. So here I'm going to say state and set state, pulling off of the useState that we declared earlier, and we're just going to give it a value of 1 to start with. So let's have a button over here, and it has an on-click that sets set state to state plus 1. We can close that button and actually show the value of state as well. So now you have a pretty intuitive understanding of how this useState hook functions. When I click this button over here, it calls setState. And that setState is the function that we just worked on, which is it sets the hook's pending state to this new state that was given, which is state plus 1, which is now 2. Then it schedules a re-render, and React just starts back with its next unit of work all the way up to the top, and it just goes through and finds that the thing that's changed is that this hook has the new state. Of course, you can just do this with just functions, which is the subject of my other talk. But now you have a concept of how this works in terms of fibers itself. And remember again, ideally, that each fiber has its own array of hooks. Here we've just implemented it at the top level for simplicity. Okay, we've done quite a bit. So far, that was about 82 lines of code. We've mixed some app code together with some framework code. And the last step to creating our own framework is basically extracting this into its own file. So here I'm going to create a new file, and I'm just going to call it something silly like react.js. And then I'm going to cut a lot of this stuff and just paste it inside of react.js. I'm going to delete the app-specific stuff like the CSS, like the app over here, and the create root call. And then I'm going to expose the stuff that I'm going to need. So I'm going to expose create root, and I'm going to expose useState. And then I'm going to export the entire React module itself. So over in my app code, I can do the same thing. I can just delete all the library code and just keep all the app-specific code. And I can say import React from ./React, the one that we just hand wrote. And we'll just say react.useState over here, as well as react.createRoot over here. And that should show up exactly the same way as it did before. Except this looks like React. We have hooks, we have JSX, we have rendering, with everything that you usually use. And that's a pretty nice result, isn't it? All right, now that we've implemented our own little React clone, we really understand the significance of this render then commit cycle, the way that we do all the reconciliation on a virtual DOM, and then we commit everything in a final step. And that lets us update the DOM using a set state on a component, and using time slicing, cooperatively schedule with the browser so that our rendering work doesn't conflict with user interactivity. And only after everything is rendered, then do we commit everything to the DOM, and then using the work loop, we'll wait for the next thing to happen. So that's almost everything I wanted to cover about Concurrent React, except for the headline feature of Concurrent React, which is suspense. And we have a little bit of time left to implement a clone of that inside of our app. All right, we're in the home stretch. So for the purposes of demoing React Suspense, we need a little backend to query against. You can obviously mock that on the front end. But for my purposes, I actually implemented that in Darklang just because it's cool. And here, basically, we have a list of strings. And you can pass in the query params of count and take, one or more dogs from that list of strings. So essentially, here's how it looks like as you query it. You can have one dog, or you can have count equals 3 and you get 3 dogs, or you can count equals 6 and get 6 dogs. You get the idea. All right, so normally you would take this API and you would go into your code and you do something like react.use effect, which we don't have yet. And then you would have some kind of fetch here, and then you would say fetch API, and then you would have the state down in here, and then then x.json, just because that's how it works. Then you have the dogs data, and then you have to set dogs. And of course, you'd have to implement this by adding another hook, purely for the sake of data manipulation. So dogs, set dogs, and then this would be an empty array. And then you would implement the dogs here. So like a dogs.map, dog with an image, and that would be that. We don't have use effect here, but that's the rough boilerplate code that you would have to do. And you would be waterfalling this request. So essentially you'd be rendering that app code, and then you have to fetch that data afterwards. So ideally you want all of this to just show up at once, because then you don't have to implement things like loading spinners. So what I've basically done is I've taken this fetch call and I've wrapped it inside of a function, and I wrap that function inside of a promise. And this promise is a special promise. It's basically a suspender. And essentially what this does is it exposes an object, and it says, and it gives you a read method. And the read method says, if the argument that you want to read is the one that I have already cached, then I can just return that result and call it status a success. If not, I'm going to throw a suspender, and the suspender is the thing that's actually a promise. The suspender says, we'll call the promise that was given, and the promise is basically the fetch dogs function. We'll call it, and we'll get that result, and then we'll set that result as our current cache. So it's a very simple cache. It only caches one result, but that's the minimal viable example that you're going to need for React Suspense. So essentially what we need to do is we need to rewrite our React render function to understand that when something is thrown, but it's a promise, then we should keep that promise result and then suspend all our work, don't render anything yet. And then when the promise is resolved, then we'll resume rendering again. Obviously, that's the most naive way of implementing it, but that will give you a good mental model of how React and React Suspense interact. So let's jump into our React module and think about how to implement this. Basically, we want to think about where do we do our rendering work? And at a high level, the place that we do our rendering work is when we perform a unit of work. And that's how we iterate through all these steps. And if any of them throw a promise, we should cast the promise, wait for the promise to resolve, and then re-render it again. So basically what we're going to do is we're going to wrap this line of code in a try block, right? And we'll catch, and we'll check that error, and we'll say if this error is an instance of the promise, then we'll stop our rendering work because now we have to suspend, right? So we'll set the next unit of work to be null, and we'll wait for that promise to resolve. So error.then. And once the promise is resolved, we can just set things back to where they were and let React re-render again. So let's see how this improves the way that we work. So over in our dog API file, we exported a function called create resource. So I'm going to import that from dog API. And I'm going to create that resource outside of my function. So resource goes create resource. This is the recommended API by the React team. And instead of all of this code, I'm just going to delete all of that. And I'm just going to say dogs equals to resource.read that current state. And now this actually starts showing up. So we no longer have to do that asynchronous dance between our effects and then we'll define an extra state. This is all just taken care of us by just having an external resource that caches our results. And we can suspend on it asynchronously, just like we can synchronously read from our hooks. So now you can see in my app, when I click next to increment that state, the resource also suspends, fetches that data, and then resumes, and then returns that result to me. So I don't have to do any of that asynchronous stuff inside of my code. It's all just synchronously reading either from the React runtime, which reads React hooks, or it asynchronously reads from the external created resource, which caches our results. And this is how you get a bunch of very good boys. So we implemented something that looks pretty close to React Suspense. It has the exact same API. I maybe fudged things a little bit with the parametric read. But essentially, this gives you the right mental model. And it's a lot easier to interact with data using React Suspense, which I'm very excited about. You also get some very good boys just by interacting with this API, which is definitely a plus. Okay, I've given you some basic understanding of what Suspense looks like under the hood, but that's far from everything that you need to know about Suspense. You should check out the blog posts by Joe Savona on the React blog about using suspense as someone who writes apps. And check out the 3 talks that were given at last year's ReactConf for more details on how to use React with best practices like render and fetch at the same time. I'll especially throw in a plug for Tanner Lindsley's React Query, which I think is the perfect data fetching library for using React Suspense. So we've covered a lot today. If you take a look back, over this past half hour, we've actually implemented everything from this list, from understanding what React fibers are, linked list traversal, rendering then commit, a hook, work loops, time slicing, create root API, and suspense. But that's not even half of what React actually gives you out of the box. And that's the message I want to leave you with today, that you as a React developer benefit from all the dogfooding that is being done at Facebook, working on the largest app on earth, as well as all the open source contributions by everyone else who uses React, including ourselves. If you're looking to deepen your knowledge of React and appreciate what it does for you, look into all of these features which we couldn't implement in a 30-minute pre-recorded video. This is all the awesome value that you get out of it. In fact, if you're feeling up to the challenge, you can even implement some of these yourself, starting from keys, hooks, suspense lists, and even some fragments, portals, and context. The more you figure things out for yourself, the less everything will seem like a black box, and the more you can do with React. That's my talk, Concurrent React from Scratch. If you want more talks from me, check out my site or connect with me on Twitter. And special thanks to Rodrigo Pombo and the React team for all the ideas here. I didn't come up with any of them. I'm just explaining it and learning it in public. If you have any follow-up questions, hit me up in the chat. I'll be around. See ya.
Hello everyone. First of all, I would like to welcome all of you at Byteconf React 2020. Today I am speaking on the topic of building scalable web applications with React.js. My name is Saeed Ahmed. I am a software engineer, open source developer, and mentor at local programming communities. I am available online on Dev, Medium, GitHub, LinkedIn, and Twitter. You can follow me, you can connect with me, or you can email me as well at saeed_dev@yahoo.com. So first of all, let's see what we will cover in this talk. In this talk, we are primarily focusing on scalability, why we are concerned with scalable web applications, what are the challenges, what are the parts of a React.js web application, what are approaches and best practices to scale. So first of all, let's see what is scalability. If we see online on Wikipedia, scalability is defined as the property of a system to handle a growing amount of work by adding resources to the system. So this definition basically deals with the scalability on the backend systems in the days back when we were concerned with the performance of our backend systems, that we liked it to scale to millions of users or maybe lakhs of users. Uh, we also wanted our server to be ideally responsive to every user, and also we wanted our DB to scale. So it was back end days when most of our logic was on the back end side of things. But in the modern era, the front end frameworks like React.js, Vue.js, and AngularJS or Angular, they have brought a lot of complex logic to front end side of things. So that's why nowadays we also have to be concerned about scalability on the front end side of things. So let's answer why we are uh, learning how to scale React.js web applications. So when we compare our three main JavaScript frameworks, that is React.js, Angular, and Vue.js, so you might know that Angular and Vue.js, they are full-fledged frameworks, while React.js is just UI part of the framework. So when you are working on React.js applications, and if someone is a newbie developer or even intermediate developer, he is more likely to mess up his project by adding a whole plethora or platter of libraries. And there are so many libraries which to, like, you might be, after seeing their documentation, you might conclude that the both libraries do the same task, but it's not like that. So this is where we should be concerned about scalability in our React.js web application, so that we are using appropriate libraries, we are properly architecting this its structure, and we are working on it following best practices. Now, when we are talking about scalability in React.js, our focus should be writing code that is easy to extend, easy to collaborate on, and easy to reuse. So these are our three main concerns. Let's talk about key considerations in the uh, scalable web applications. So first of all, there are dynamic requirements which change according to user's device, you might say, or user's network, or like if they are using 3G network or 2G network or 4G or maybe 5G. So you have to deal with all these scenarios that your web applications, your React.js web application works uh, good on all of the network types. And also if a user has a slow machine or he has a fast one, so you have to deal with all these scenarios, like that he gets almost identical experience on all of the devices. Then there is modularity part. Ideally, we want our code base to be modular so that if someone adds something to it or someone removes something from it, so it's easier for him, her to add things and remove things. The final goal is that it doesn't break, like it has the parts of your code base are less dependent on each other. Then there comes state management, which is a common concern for developers, uh, specifically in React.js. So we need a global state management solution which is both traceable and predictable. Then comes the performance part, in which React.js or every front-end developer is concerned that his web application is working uh, good performance-wise, like it's good in load times, it's good in optimization and all the related things. So there are many techniques to do this as well. Now let us see how to scale, how to use libraries or packages efficiently. So first of all, let's see the UI part in a React.js web applications. There are three things about which we are more concerned. First of all, a boilerplate code, or you may say it a starter kit, then UI libraries, then there is styling part. So let's discuss different starter kits. So there is a create react app CRA, which is official for building client side single page apps. Then there is you may find React Redux boilerplate online, which is with Redux state management. Then there is uh, React app plus Redux plus React router for mid-sized application with Redux and Redux Thunk for middleware management. Then there is a more famous React boilerplate by Max Stoiber, which is a bit complex, and it has Redux Saga for middleware and side effects. Then there are some server side and static side generators like Next.js and gatsby for static side generation. So basically, these are the starter kits which you can consider for your particular use case when you are starting out a React.js web application. Then comes the UI libraries part. First of all, we can discuss Material UI, which is a popular UI library for React based on Google Material Design. Then there is React Strap, which are UI components and layouts based on Bootstrap 4. Then there is Prime React, which is rich UI components, including charts, data grid, and other complex things. So these are different UI libraries which you can use to use according to your particular use case. Now let's discuss the styling part of your web application. So when you are building React.js web applications, it's a fact that React.js core design principle is HTML within JavaScript, which you commonly know as JSX. So normal loading of CSS or Sass within JavaScript components doesn't go well with the architecture and design pattern of React.js, and so the performance. So we know that React.js is lightweight and very flexible, so there are many third-party tools to style your applications and components. First of all, let's discuss style components, which is highly customizable, easy to read, structured, goes well with the components and JSX development, and it also enables global, local, and component-wise themes for you. Then there is Tailwind CSS, which is a utility-based CSS framework, very easy to create custom CSS. It's readable and goes well with the components and JSX development. It also enables global, local, and component themes. Then there is React JSS, which uses most popular JSS, like which is commonly known as CSS and JS within React, widely used by static site generators, and it has also support for server side rendering. It also enables global and component themes. So if you are using some UI based library like Material UI, so it provides its own methodology for styling. Like for instance, Material UI uses style components. So this is the way in which you can improve your working on the UI part by using starter kits and UI libraries and styling which is relevant to your use case. The next is our interface part. Basically, interface acts as a bridge between your components and the middleware. This is where our first test of choosing libraries gets in place. React.js is just a view. So for routing, for modeling, and for models, we need to rely on third-party libraries. However, first of all, let's discuss routing. So React Router is the default choice and also recommended by React.js team. This is widely used in React.js applications, and it can work most probably for your use case too. Another great alternative is Reach Router. It's fairly new. It has been forked from React Router, so it's simple, config based, and has most needed features built in, including nested routes, relative links, animations, accessibility. It works for simple medium apps and where state management patterns like Redux is not used. Also, you can use React Loadable for the lazy loading of routed components, dynamic imports, and code splitting. So here you can see the flexibility in the architecture of React.js web applications. Like you can use any kind of library which is particular to your use case, or you can also use the recommended uh, packages or libraries which work for most of the use cases. So that's the beauty of React.js. Next, let's talk about the next big thing. So it's state management. So designing and maintaining state is critical in front-end web applications, and most of the time developers are concerned about state management. So we already know that there are two states basically in React.js web applications. One is your local state, which you can use for small apps with no nested child components, and so you don't need to where you don't need to pass data between child to parent. So local state can be useful for medium large apps. You can use local component state and persist it for pagination, sorting, highlighting, and all kind of these things. Next comes in global state. So when we talk about global state, we have got two solutions. One is the context API. Context API is great when we want to store in a global place and share it across all components. That's our state. This way we can avoid passing loads of props to nested components. But remember that context API is commonly and recommended for data sharing across components like locale, theme, master data cache, which does not change frequently. So you have to keep you have to use store as minimum as possible, because if you use it more and redundantly, so it will be slow. Another great solution is Redux or MobX for the global state. So once your web application grows, then neither local state can help you nor context API helps in ensuring maintainability and performance. So basically, debugging becomes a nightmare for developers. So we either choose Redux or MobX. So MobX is for small medium applications which are lightweight, like they don't have complex transactional logic, and you want to quickly jump in, and you are familiar with object oriented concepts, so it's easy to pick up for you. On the other hand, Redux is primarily for large applications which have many data sets to manage and need a single source of truth which is testable and debuggable. It does have a steep learning curve but has a great community support and tooling. It's opinionated and follows functional programming paradigm. So if you are from a functional background, then it will be easy to pick up for you. The next big thing is about business logic and middleware. This is the most challenging and complex decision to make in React.js. The reason being it's a Vue library, and with multiple other libraries to manage state like Redux, middlewares like Saga, Thunk, it's easy to get confused on where to place your business logic. Again, there are multiple options depending on the usage of Redux, Redux Saga, or Redux Thunk, or any other middleware. So Actions creator are where you typically have your business logic. Calling services at this is the first one triggered upon user action and calls reducer to manage state. So the pros are they're easy to identify by any developer, and they are ideal for simple use cases and business logic. While cons are that you cannot make async calls for multiple requests, and also you don't have any access to global state. So using action creators for business logic for is very simple, and there is no need to for multiple service request handling workflow logic, no dependency with global state. On the other hand, you can also write your business logic in the reducers. It's easier, and business logic can decide the new state, like there is no complex data flow. But also reducers are synchronous, so async operations are not possible. And also when you are putting your business logic inside reducers, it negates the design principles of the redux. So, so ideally you should not be using reducers for business logic. Use it only for learning purpose, or your logic is tightly coupled with state. Then let's talk about the middleware part. So first of all, let us discuss Thunk. So the pros of Thunk are that it is easy to identify by any developer and focused, and it has access to global state. The cons are that there is no easy way to cancel pending request. You can also cannot add further interception to augment your actions. So in a nutshell, you can use Thunks for business logic for medium complexity, and there is no need for augmenting multiple actions for logging, error handling, further request, or interceptors. Then for when you are dealing with complex situations, triggering workflows, augmenting actions for multiple requests, then Redux Saga is a good approach. The pros are that if you can perform canceling, and it's very easy to test. Like there are action creators which dispatch objects, and Saga does everything else, so it's easier to test. Mm, Cons are that it's complex to understand, and also there are no interceptions possible. So Redux Saga, you can use it for primarily for business logic in medium complex applications. Then let's talk about communication gateways. Since you know that React.js is a Vue library, so you have to rely on third party for API calls. Like you can use Axios, which is a promise-based HTTP client. This is lightweight. This is very popular as its root is based on Angular's HTTP service. Then there is Fetch API, which is native JavaScript Fetch API. And there is API source, which is lightweight wrapper for Axios. API source is better structured flow and can be used in React Native as well. And then there is Apollo, which is one and only client for GraphQL based requests. So if you are using GraphQL, so you are more likely to use Apollo in your web application. Then there comes interceptor part. So when you are dealing with large data sets which are nested, you may want to intercept incoming data, normalize it so that it can be rendered easily with performance on your components. So thankfully we have a library normalizer which does this on our part. Also, you should never rely on same schema structure which is coming from your backend, like the data set received from API, as it may not be optimized, normalized the way UI components need to be rendered. Now let's discuss some of the best practices to architect our web applications in React.js. So first of all, it's a recommended way, or more better way you can say, is grouping by features. So it's like to locate your CSS, JS, and test together inside folders, group by feature or route. So you can put, like, if there is a feed route for you, so you can put all of the JS, CSS, and test file related to that in a single folder. So the definition of feature is not universal as per React.js documentation, and it's up to you to choose the granularity. If you can't come up with a list of top level folders, you can ask the users of your products what major parts it consists of and use their mental model as a blueprint. The second best practice is to keep an eye on extra re-renders. So there is a lifecycle method which is componented update, or you can also do it with hooks. So in it you can compare the previous props and next props, and then you can re-render your component or not. So you can make a decision in it, or also you can use some tools like React Dev tools to uh, trick, track the performance of your component, that whether it's re-rendering extra or not. So you can make that decision with the help of these tools as well. The third best practice is to use sagas. So in sagas you can avoid callback hell, with meaning that you can avoid passing in functions and calling them inside. Additionally, you can also more easily test your asynchronous data flow. The call and put methods return JavaScript objects. Thus, you can simply test each value yielded by your Saga functions with an equality comparison. On the other hand, Redux Thunk returns promises which are most difficult to test. So testing thunks often requires mocking of the fetch APIs, exhaust requests, or other functions. With Redux Saga, you don't need to mock up functions wrapped with effects. This makes tests cleanable, clean, readable, and easier to write. So that's it from my side, and thank you so much for listening to me. And you can always contact me at the rate I am Said Dev on Twitter. So I'm ready there to answer your questions.
Hello everyone, thank you for inviting me to Byteconf React. My name is Neha Sharma. I work as UI manager. I also run a community named JS Lovers and I love to do calligraphy. This is my Instagram handle and you can visit it to see my work. Today I'm going to talk about accessibility in React apps. Before moving to React, I want to talk about the basics of accessibility, what accessibility is, why it matters, and its different levels. So the first thing is what is this A11Y? A11Y stands for accessibility and why? Because there are 11 characters between A and Y. That's why. So from now onwards, whenever you see A11Y, it means they are talking about accessibility. So what accessibility is and why it matters? Accessibility means that whatever the content and information we are pushing in the digital world should be accessible by everyone. When we say everyone, it means disabled people and non-disabled people. And why? In the current situation of COVID-19, everyone is purchasing stuff online. These are the essentials, these are the groceries, hand sanitizer, medicines, and so on. If your application, if you are a pharmacy business owner and your website, if your product is not accessible on mobile or if it's not accessible by keyboards or screen reader, then obviously you are stopping a user from accessing the information, accessing the medicines they really want to buy. And there are so many things you are actually, just because your website is not accessible, they are not able to access it. So that's why accessibility is very, very important. So whatever you are pushing in the digital world, it should be accessible by everyone. So who is behind this accessibility guidelines? Are there any accessibility guidelines? Yes, there are accessibility guidelines. There are levels. WCAG is behind that. You can visit their website and read about the rules and regulations. There are three levels of accessibility: single A, double A, triple A. Single A is the minimum, double A is expected, and triple A is the highest. There are a lot of countries which do have laws and rules, regulations around accessibility. So whatever, if you are building something and it's not accessible, the users can sue you. However, there are still countries which don't have any rules or law against accessibility. Please, for them, try to achieve double A level of accessibility. If you are working on the federal websites, triple A is the expected level, so please be aware of it. Now, how many types of different disabilities we have? There are vision, hear, speak, cognitive, and more. But the bottom line here, to make sure that you all know, is these disabilities could be permanent or could be temporary. And why? I have seen in my career, there are product managers, there are project managers who says that our end user, our focus users uh, are not disabled, or our product is not for disabled people. But you need to understand, might be your current user might get some eye infection, or might get his or her hand got injured, and now that person is not able to access or do the stuff that person was able to do before the injury, because your application was not is not accessible. You are again stopping that person from getting the information from the digital world. So please make sure that your application is accessible. These problems could be permanent or could be disabled. You cannot control that. The only thing you can control is making sure your application is accessible by everyone in any condition. Now, coming to the myth one, as I mentioned, accessibility is only for disabled people. So whenever people hear accessibility, they start thinking about disabled people, and then they start thinking about keyboard and screen reader. But this is not true, because accessibility is also about, is it accessible on mobile? Is your website is getting load on time? Is the content is perceivable or understandable? Is the UX is good? Is it consistent? Is it easy to understand or not? And yes, obviously, is it accessible by keyboard? Is it accessible by screen reader? So if you will see, the top 4 points are not just related to disabled people. Everyone nowadays is on mobile. Everyone wants everything to open fast. Everyone don't want to read a content by just opening a dictionary next to it. Everyone wants us consistency in UX, which is very easy to understand, and in very short span of time they can do, or they can get the information they are looking for. So accessibility is not just limited to disabled people, and also accessibility is not just limited to keyboard and screen readers. This is very important to understand. Now the second myth is accessibility is very hard. This is the biggest excuse I have seen, that achieving accessibility is very hard. But we need to understand that it is not so hard. If you will start using semantic tags of HTML, you will see that a lot of issues are automatically will get resolved. All you need to do is just start using semantic tags of HTML. If you will follow the semantic tags, you will see that automatically your keyboard support is also getting in shape. One more thing you need to take care of when you are working on the keyboard support, in CSS there is outline property. Never ever disable it. The reason is the blue line you see on different browser and OS, that default blue line indicate the keyboard user where the focus right now is. If you will remove it, again you are removing the keyboard support. So please have that. If you will follow the first and second point, you will see in screen readers, when you are doing the screen reader testing, these most of the screen reader issues are not there now. The only at the few places you need to do some changes. So again, what you are saying is, if you will follow yourself from first point, slowly with on every step, your work is getting lesser. Now, last but not the least, alt tags. If you are using images, you need to take care of alt tags. Now, there is a one problem. People assume that every image should have alt tag. Nope. If you have decorative images, there is no need to put alt tag. If your caption, if you are going to have the same caption and same alt tag, please don't do that, because screen readers are going to read aloud your alt tag, and again they are going to read aloud caption, which is a repetitive information. So don't do that. And never ever start alt tag with this is an image or this is a graphic. Always think like an end user. If a person cannot see that image, how would you like to explain that image to that person? So that should be your alt tag. So please focus on these four things, and these four things are not so hard to do. These are very simple basic HTML things which any developer can do. So hence accessibility is not hard. Now the third thing is accessibility is not possible with JS frameworks. Nowadays, most of the developers, most of the apps are using JS frameworks. Are they not accessible? Is React is not taking care of accessibility? Well, this is not true, because React is having a dedicated page talking about accessibility only. A page where they give the hints, code samples, that how to support accessibility and different level of accessibility. So this is not true that React doesn't support accessibility. In fact, we as a developer should take the advantage of React components. When we are working on the React components, we are just focusing on one single component. So we are focusing on its components UI, the UX, UI, responsiveness, business logic, and that is the correct time to focus on the accessibility of that component. We should take the advantage of that. And if we are not taking the advantage of that, then obviously we are doing wrong, not the framework is doing the wrong. Now, the first rule when you are working on React apps for accessibility to understand, your JSX is not equals to semantic HTML. The code in front of you, you can see this is a header component, where in the JSX I'm using a div to create a header. Might be a lot of people will say there's nothing wrong, but you need to understand that there is already a header tag available in HTML. So instead of using a custom tag, I would prefer to use a native tag. Reason, it will take care of a lot of things under the hood for me, especially for the screen readers. Now when the screen reader will come, it will automatically read aloud header. So now I don't need to write extra code just for screen reader support. Now the second example is, here I'm trying to create a button. If you will see in the JSX, I'm using a div. On that div I'm creating on I'm putting on click. Now if I want to have accessibility on this, I need to pass role, aria, I need to have the focus, I need to have the tab index, and so many things. But If I will just use HTML button tag, it will take a lot of my headache of accessibility by itself under the hood, and I don't need to worry about screen readers. I don't need to worry about focus. I don't need to worry about tab index and so many things. So always use native elements above the custom elements. This is very, very important. Always validate the HTML or JSX you are writing. It's very important for accessibility. Now the second thing is keyboard support. So there are multiple things you need to take care on in keyboard support. The first thing is outline, which I already spoke about, that when you have the outline in the CSS, do not disable it. But there are times when you want forcefully the focus to come or keyboard focus to come. In those cases, we use tab index. Now the tab index has three values: 0, positive, and negative. So first I will talk about 0. It means that the element should be focusable in sequential keyboard navigation, but its order is defined by the document source code. So by default, your button, your A tags, your input tags, whenever you are going to use keyboard tab, the focus will come there. But if there is an element in between where you want the focus to come, you can use tab index and put 0 there. So it will follow the sequential order and it will come there. But if you are using a positive value of tab index, then again, then what will happen is the order will be defined by the value of number. So if you want to move element order first before it is a particular element, you can use a positive number. Now the last one is negative value. Negative value means that now the element is not reachable by sequential keyboard navigation, but now you can move, you can have the focus on that by using just JavaScript. So in most of the custom components, you will be using tab index with minus value. Now, I talked about the forceful focus and all that, how we can have that. For that, you can use the focus, and in the JavaScript, in the React, to have the DOM element reference, you will use refs. So these are the 4 things you need to take care when you are working on the keyboard support. Now the next thing is you need to think logical, because when you are making a custom components or module, you need to think logically how the keyboard focus should move. So one of the example I can give is your dialog boxes. When your dialog box is getting open, you need to think that how you want the order of the tab index of the keyboard support should go. Now the last but not the least, skip to main content. This is a very important thing to improve the page accessibility. So if you are an e-commerce application and you have a big top navigation, now you don't want that whenever a user is coming on uh, every page, that navigation should not, screen reader should not repeat the navigation again and again. So what we should do is we should implement skip to main content. So the moment the user is coming on a new page and the moment they press their first tab, the option to skip to main content should come. And this is very important because I have seen that in products like e-commerce application, whenever I'm using screen reader or whenever I'm trying to access by keyboard, whenever I'm going in the internal pages, I have to do so many tabs, which I call as tab hell, because it's like tab I'm doing. The good example is of Amazon. If you will go to their internal pages, the moment you press the tab, they give you the option of skip to main content, and by just pressing that, I move. I don't need to tap to their navigation or side navigation. I simply jump to their main content. Now, if you will see here, the example of tab index 0, I was having LIs, and in that I wanted the LI should get focus. So that's why I use tab index 0 here. Then in this example, I'm trying to create a drop down. Now to get, there is no semantic element available in HTML for drop down. So I have used button and UL. Now what I am doing is, this is what I'm doing, that whenever there is a tab is happening, I'm toggling the visibility of my UL LI, and the moment it is getting open, I am forcefully moving this focus to the A tag. So on line number 17, I have forcefully moved the focus to the A link, and I used the reference, use ref hook to get the reference of the list. So this is how you do it. So whenever you are building in React application, anything which requires the keyboard support, you need to have a button there. And whenever you are having anything where you need the focus to be, you need to use focus method, you need to use tab index, and to get the reference of that particular element, you need to use ref or use ref hook of the React. Sorry. Now the third thing is page title. Page titles are very important for the screen readers especially, because when the user is dependent upon the screen reader, and in single page application there is no refresh happening, so no page title is getting ever updated. Now a person you move from home page to product list to product detail to cart, but due to there is no refresh and the page title remain the same, the screen reader user will never ever able to understand that when this whole transition happened. So it is very important to change your page titles with every route. It's very important. Unfortunately, a lot of developers doesn't know about the importance of page title. So next time whenever you are changing the route, think about changing the titles also, so that the screen readers can understand that now you reach to a new page. The next thing is accessible forms. Forms are the very important part of any application. I believe that they drive the business. If you are an e-commerce application, forms are getting used for getting the addresses, payment information. If you are a business, forms are getting used for the collecting the leads. If your forms are not accessible, then obviously you are losing your business. One of the example could be the university. If you are a university business owner and your university forms where the students can come and submit their application, if your forms are not accessible, you are losing your students. So in React, the first thing you need to take care of for your screen readers, it is very important on line number 6 to have HTML4. What HTML4 stands for, they speak aloud for the screen readers that what this particular input is about. It is for name, it is for email, it is for filling the address. So your HTML4 is very important. Another thing to take care is on line number 7, your HTML4 name should match the ID name. So these things should be same. Only then the screen reader will able to speak aloud and identify that which input tag this is. Now the second thing is coming to line number 22. If you have an input field where there is no label available, in such cases you need to put aria labeled by. So even though you don't have a label, but screen readers will now read aloud aria labeled by and tell the screen reader user that this is the label of this particular field. So this is how you need to do. These are the basic things, but you need to take care of these things a lot. Last but not the least, you need to take care of the errors of the success, which I'm going to talk now. So live regions. Now, when you have a single page application, visually it is very easy to see where the errors are coming on submission, where the success messages are coming, or which part of the page got updated. But when you are dependent upon the screen readers, you won't be able to understand when such things happen. In such cases, live regions come. So you have an ARIA tag for that, ARIA live polite. So what it does is whenever a change is happening on the page, it will alert the screen readers that here is your error or this error came. This notify the screen reader that some change happened on the page. So hence this is very important. Now apart from the forms where you should use it, you should, if you are an e-commerce application, you should use it when an item is getting added in the cart. I have seen few e-commerce application where as a screen reader user, I never able to understand when my item got added to cart because there is no ARIA live notification there. So think about this. These are the small things as you have seen. This is not hard. All you need to do is just add extra attributes and think logically from the point of view the keyboard or screen reader users, and you would be there. And also, as you can see, even if you are building in React.js, this is not a hard thing. React.js is already talking about the accessibility by giving a documentation about this. It is us as the developer who has to step up and take care of accessibility in our code. Moving ahead, what are the tools available to do this? So there are a lot of tools available. As a developer, I will start from the bottom first. So these are the plugins, these are the extension available. You can integrate with your favorite IDE, and while you are doing the coding, it will help you in giving the warnings and errors, and you can fix those on the fly. Now from the top, all fours are the extension which you can use. These are pretty good. I use Lighthouse X Wave a lot. The advantage of using Lighthouse, they have a CLI. So if you have a project and in which you are using CI/CD, you can integrate your Lighthouse in that. It will give you the score of accessibility. So it is very good. With every commit, you get to know if a particular component or story is breaking the accessibility, if your score is going down. Another thing is, if your project is already done, what you can do is you can run Lighthouse X or Wave on that and even accessibility insights, and it will give you the scores and errors with solution, and then you can fix those. So this is going to help you in fixing your existing project with accessibility perspective. So please take the advantage of these tools. These tools are free. Only X do have their free version and also have the paid version. So if your company is ready to invest, I would say this is not going to be a useless investment of your company's budget. So please utilize that. This is all about accessibility in React apps. I hope you learned something out of this, and I hope that you are going to implement accessibility in your project. Thank you so much.
Hey everyone, welcome to Byteconf React 2020. I'm Sam Juline, and I am a developer advocate engineer for Auth0. We're an identity as a service company. Basically, we build auth for developers. So I'm coming to you from the rural Pacific Northwest. I live on some land with my partner Amy and a bunch of chickens and barn cats and a dog. It's a great time. I hope all of you are doing well right now. And my talk is about adding auth to Gatsby, powering up Gatsby with auth. One thing that I get asked a lot about is whether adding auth to Gatsby is the same as it is when you just have a regular React application. And it turns out there are a few things that are different. So in this talk, I'm going to show you how Gatsby makes the distinction between build time and runtime. We're going to talk about using hooks and context to add auth to a React and Gatsby application, and we're going to look at some special Gatsby bits that you need to be mindful of when you're adding auth to Gatsby. So I hope you learn a lot. Please feel free to reach out to me on Twitter at SamJuline if you have any questions or need any help with anything. I'm always happy to help. And yeah, let's dive in. Hey everybody, welcome to Power Up Gatsby with Authentication. So I love Gatsby, and I love teaching about Gatsby. There's something about it that's just so easy to use, and you can set it up with Markdown or MDX. Something about it just really feeds my love of writing and my love of coding. It's just great. I just love it. Like a lot of people, probably most people, I discovered Gatsby as a static site generator, kind of like an alternative to Jekyll. I thought that you could use Gatsby to generate blogs or sales pages or other static sites, things like that. I didn't realize at first, and I think most people don't realize, that Gatsby's really more of a framework. It's a framework that can build dynamic React sites in addition to just generating static pages. The Gatsby folks like to say that it's a blazing fast web and app framework, so not just a static site generator. Okay, so Gatsby can do both static sites and dynamic sites. We've established that, but this leads to some interesting quandaries with Gatsby. For example, take authentication. Is doing authentication in Gatsby the same as doing it in React? It kind of makes you think. How does that work anyway? Maybe you've tried to implement auth in Gatsby and run into some weird errors or something. Or maybe you've had everything working and then you run Gatsby build and everything breaks. What's up with that? Why does it do that? Well, that's what we're going to try to cover in this talk. So we're going to talk about, first, the distinction Gatsby makes between build time and runtime. What happens in each of those? Then we're going to talk about using hooks and context for authentication in React. Finally, we're going to start talking about special Gatsby bits, things that you're going to find you have to do differently in Gatsby versus a plain old vanilla React application. So I'm Sam Juline. I am a developer advocate at Auth0. I'm a Google developer expert for web technologies and Angular. I'm also an instructor for Thinkster and Egghead. I do a lot of content on both React and Angular. You can find me on both Twitter and Twitch at Sam Juline. Okay, so let's talk about build time versus runtime. Gatsby makes this distinction between build time and runtime. So what do we mean by that? Build time means the process of using the server to compile the site into files that can just be delivered to a web browser later. What's important to know about this part of things is that there's no browser APIs available to you here. Something like window or document just doesn't exist in the build time. So that's build time, basically the server side of things. And then you have runtime. Runtime refers to the processes that happen in the browser when you click through and interact with it. So JavaScript is running in the browser, and you have all of those APIs like window and document and things like that. Let's talk about the runtime first in this scenario. So let's look at Gatsby and authentication in the runtime, which is really mostly just like React plus auth in the browser. So this auth flow, what does it look like? Well, first, we're going to kick off the login process, usually using some sort of login button or something like that. Then we end up going over to a provider of some kind, an identity provider, and then the provider sends us back to our page, and we need to handle that redirect somehow. When we handle that redirect, we're usually working with an auth SDK, and then that SDK helps us process success or error, where we get the user and the token, and then maybe send the user to some sort of protected route through a redirect. So this brings us to the second part of this talk, which is using hooks for auth. So when you have a React application, you can use auth with hooks and context. What do I mean by this? How do we set this up? The first thing we would do is create an auth utility. This auth utility is going to do a few things for us. It's going to store the token and the user in memory. It's going to interact with your auth SDK that you're using, and it's going to handle all of that redirect logic for you. It's sort of like a single source of truth for all things auth in your React or Gatsby application. In this utility, the first thing we're going to do is we're going to create a context, an auth context using React's create context. Now, notice here, because we're in Gatsby, we're going to use a default context and pass that in. Now, we're going to come back to that. We're not going to talk about that yet, but keep that in mind. Then once we create the context, we can use the use context hook to create a hook called use auth, and that lets us just access that context. So in the auth utility, the next thing we need to do is define the auth provider. So this auth provider, we're going to give it the children and then any sort of initialization options. But what do we put inside of this provider? Well, there's going to be a lot happening here, so let's take it one piece at a time. The first thing we need to do is create a bunch of state. We got to set up a bunch of state using use state hooks. So first, if your auth SDK has some sort of client that you're going to need to access, you're going to need to keep track of the instance of that client. So we'd use a hook for that with use state. And then we would also create state with use state for anything we're going to need to keep track of. So is authenticated, the token, the user, and then maybe we're going to drive some UI state with just sort of a loading or set loading. So we do that as well. And then next, we need to create a use effect hook. So we're probably going to need to initialize the auth client and set up some initial state of this application. So that's what we're going to do with the use effect hook. So we're going to define this async function called init auth. And then once we've created that, we're going to create our client and set our auth with auth from hook. And then we also need to see if when this app is loading, if we are in the middle of a redirect. So if we are, then we need to go process the response from the server and set up the rest of our app. If we're not, then we need to move on to the second half of this use effect function. So we have is authenticated, and we're going to check that from the SDK and set that with our hook. And then we're going to, if we are authenticated, we'll go get the user, set the user with our hook, and then we can set loading to false. So after we've defined that function, we'll go ahead and initialize it, and then we'll move on to the rest of our context. So after the use effect, we would start to define any of the methods that we need in this auth utility that aren't provided to us by the auth SDK. So, for example, we might have a handle redirect callback function like you see here, and inside of that we need to do things to handle the callback and then use all of the hooks that we've created to set up the state of the application. Once we've defined all those functions, then it's time to return our provider for the auth context. So notice here, we're going to create this provider, wrap it around our children, and then the value that we're going to give this provider is going to include all of the things that we've defined, like the user and the token and any functions we've defined. And then we're also going to pass in any functions that are just going to wrap SDK functions. So like we have this get token silently on our auth client that we're going to wrap in a get token function, and we can do that for however many we need to do. So now we have this auth context provider. And this means that our auth utility does all kinds of things for us. It stores the user and the token in memory. It interacts with the auth SDK. and it handles all of the redirect logic. But we have a bit of a dilemma here. In a regular React app, we just wrap our app component with the provider. But where is the app component in Gatsby? There is a way to expose it, but is that really what we want to do? So this brings us to the first of 3 special Gatsby bits when it comes to auth. So we need to figure out where to put this auth provider. And it turns out Gatsby gives us a way to do this. Instead of trying to get into exposing the actual app component, we can create this file called Gatsby browser.js to tap into the runtime side of things. So we can export this function here called wrap root element, and Gatsby will provide us the root element for the page. So inside of that, we can just wrap our auth provider around the root element, and of course, we would need to pass in any sort of configuration that we have. Okay, so we're pretty much set up, but does our app actually work? Well, the answer to that is maybe, or it depends. You may find that when you run Gatsby develop, everything is just running smoothly, everything's working fine. But when you run Gatsby build, things, well, let's just say they don't quite work as expected. The app doesn't build and you get all kinds of errors. Why is this? What's going on here? So remember I said that we have build time and run time. And in the build time, Gatsby's trying to go get all of your files and turn them into static pages. So these issues that you're running into have to do with the build time. So first, remember, let's go back to when we created our context. Remember I had said that we need to pass in a default context here. This is our second special Gatsby bit here. What do they mean by that? Why do we do that? Well, the default context is going to look like this, where we have these default values for the values that we're giving our context. So we have things like is authenticated set to false and a fake function for login that doesn't return anything. Normally, we don't need to do this. In a regular React application, we probably don't need to worry about providing these default values because we just create default values when we do our use state. But this won't actually work in Gatsby. Why is that? Why do we need to do this? Let's look at an example to understand why. Let's say you have a navbar component, okay? So this navbar component, it uses our useauth hook. We go get is authenticated, log in, and log out, and then we check if we're authenticated, and if we're not, we'll display the login button in the navbar. If we are, then we'll go ahead and display a link to the profile and a logout button. Seems straightforward enough. But what happens if we use this in a Gatsby page? Things get a little bit more complicated. When I say Gatsby page, I mean one of those JavaScript files in the pages directory that Gatsby just magically turns into a route. So these are going through the Gatsby build process. And so let's say we have index.js here, and that index, that page uses the navbar, and on top of that, it uses the useauth hook to go get that loading value that we have and then display a loading div. Okay, well, what happens here is when Gatsby goes to try to render this file on the build process, it encounters a problem because it's looking for values for that context and it doesn't find any. It's looking for the value of the useauth hook and nothing's happening. So it breaks. And so we can fix that by going ahead and providing a default context to Gatsby. So now when Gatsby tries to build that page for you, it actually finds values that are defaults and generates that for you. And then when the page is actually running in the browser, then React will take over and provide all those values in the context. So the next special bit that we come into, the final special bit actually, is in the build time. Remember that I said that we don't have browser APIs available. So we're not going to have things like window or document. One thing you're really going to have to watch out for are dependencies that use these browser APIs like window or document. And spoilers, auth libraries usually do this a lot, because auth involves a lot of redirects and pop-ups. So you're doing things like checking window.location, or maybe you're showing or hiding a pop-up, a lot of things having to do with the browser, and that's going to break things. So there's two things that we can do about this. First, we can create a file called gatsby.js. This lets us tap into kind of the server-side build pipeline of Gatsby and mess with it. So we can create that file if it doesn't exist, and Gatsby allows you to override this function called onCreateWebpackConfig, and it provides you these things, the stage, the loaders, and the actions that you can use to tinker with your Webpack pipeline here. So inside of that function, we can check to see if we're in the build HTML stage. And if we are, then we can pass in an object that will change our Webpack config. So we'll create this object of the module, and we're just going to pass in a rule that's going to tell Webpack, if it finds the name of your auth SDK, to just go ahead and ignore it. Use a null loader for it. And this is going to fix this build problem for us. You may also need to conditionally set values depending on if you're in the browser. For example, you could create a Boolean value here called isBrowser that just checks to see if window is defined or undefined. And then you could wrap whatever browser-specific function you want inside of that check. So check, hey, if we're in the browser, then run this function called change window location. Okay, I've hit you with a lot of information here, so let's do a quick review. Gatsby is a much more powerful platform than it sort of gives off as an impression, right? We tend to think of Gatsby as the static site generator, and it turns out that it's more of a framework. It can do both the static side of things and the dynamic side of things. When people don't realize this, though, it can cause some confusion, especially around topics like auth. It gets really confusing to know whether implementing auth is just the same as doing it in regular React applications, or if there's something special that you need to know. And so that confusion often leads to frustration, because we try to implement auth in a Gatsby app as if we were doing a regular React app, and things don't go our way. Things start to break. What we don't realize is that Gatsby is actually doing a build process in addition to the runtime when you run your app. So first we looked at the runtime side of things, and we looked at how when you log in to your application, you get sent off to a provider and sent back with a redirect, and then you have to go through and process with your auth SDK the success response to go process the user, the token, and then where to send the user. So in React, we get to use hooks and context to build this nice auth utility that provides a context that does things like stores the user and the token, interacts with the auth SDK, and handles all our redirect logic. So we create a context and then a hook for that context, and we ultimately return this provider that has all of our values and functions. And then we run into these weird Gatsby things, and that's just because of the build process, which is actually your friend in the end, but it can trip you up. So one thing we need to do is provide a default context here. We can't just rely on the browser, because Gatsby is going to run through this in the server side of things, in the build process. So we provide this default context so that Gatsby, when it looks for values of things like the useAuth hook, it can find those default values and generate the static pages that you need. We also looked at how the build time doesn't have access to browser APIs. So you're going to need to do things like check for dependencies that use browser APIs like window or document. And auth libraries are notorious for this just because auth so heavily relies on redirects and pop-ups. If you do find dependencies like that, like your auth SDK, you can tap into your Webpack pipeline and just ignore that during the build. And you can do things like check if you're in the browser and only set values or run functions or something like that if you're in the browser. So I hope this helps clear up some of these issues with Gatsby and authentication. Once you get the hang of this distinction between the server and the build and the runtime, it helps make things a lot easier. So you can find the slides and sample code and things like that at samj.im/byteconf react. Thanks so much for watching, and I hope you have a great rest of the conference. If you have any questions or need any help with anything, don't hesitate to reach out to me on Twitter at @SamJulene.
Hello guys, my name is Andrei, and I'm broadcasting from my den in the cruel and cold motherland of all hackers, Russia. And today we're going to talk about state management in React, specifically when we should follow and when we should not follow one of the 12 golden rules of React, lifting state up. We'll push that concept to its limits. We'll see where it fails and why. And we'll also cover how we can work around it. But before we get started, let me say a few words about myself and about my company. I like calling myself a full-stack TypeScript and JavaScript developer. I used to work for two major outsourced companies in Russia, software consultancies, and now I'm super happy to be a part of the family at Hazelcast. And I truly love open source. So, the company, Hazelcast, what do we do? We are building a fancy distributed enterprise in-memory data grid, which basically a fancy word for distributed cache. I just have to say that we are scalable, we are easy deployable, we are distributed, and you can even choose which side of the CAP triangle we're gonna be, AP or CP. We have cool features like near cache. We are open source, and clients for lots of languages are at your disposal. Now our marketing department is not going to put a bounty on my head, and I'm not gonna lose my job. Woohoo! At one of our internal hackathons, I came up with an idea to display our cluster as a graph. Real graph with vertices and edges and stuff like that. Just so you can imagine the scale, we could potentially have up to several hundreds of nodes and several thousands of clients. And the data in that cluster is distributed in partitions, hundreds of partitions between all the members. So potentially, I was facing a challenge of displaying tens, thousands of nodes, DOM nodes, on a single screen. Well, on that day, the demo went smoothly because, well, it's a demo, and I just ran a cluster of 3 nodes with, I think it was 10 clients or something like that. So that's how all demos work, right? You just take the sunny day scenario and show it. But it got me thinking, how exactly the React is going to play with displaying tens, thousands of nodes, and what is the upper limit which React can handle comfortably. So I decided to reproduce the case in a very simple manner and to build a naive, simple data grid. And that's exactly what we're gonna do today. So what's the most natural way to store the state for that grid? For me, it would be to store that state somewhere high in the hierarchy and pass the chunks of that state as props to the children. And that's exactly what lifting state up proposes. So our plan for today is to lift state up, create a naive implementation of that data grid, refactor it using standard practices, see where it fails and why, and then try to move our state down and see if it helps or not. So let's get to the coding part. I have a confession to make. I'm not that good at live coding, so we're not actually gonna do real live coding. I have prepared several commits, and I'm going to apply these commits one by one. We will overview the code, the changes, and see how these changes affect the real application. What exactly we're gonna build? Let me show you. Here we go. It's a simple grid, and if you click on a cell, it displays a checkbox. Pretty simple and straightforward. Now let's go to the code and see what we have. So we have 2 components, app and cell. In the app component, we have some state, which is a 2-dimensional array of size by size, and now it's 10. For that field, well, we run over each row, and for each row, we run over it to display a single cell. And we also have a cell component which accepts its current state or content, and it accepts a callback set content to, well, set that checkbox, right? So we immutably copy all the rows except the target row, and for the target row, we immutably copy each cell and update the content of the target cell. So let's go back to our data grid and see that it actually works. Yeah, cool, it works. And now what we're gonna do is we're going to increase the size of that field to say 100. Let's go back, see if it's really 100. Yeah, it's 100, definitely. Let's click. Well, it's still pretty fast. So thanks to the awesome from DevTools team, we can go to the performance tab and slow down my CPU. So now when my CPU is 6 times slower than it was, let's do some clicking, click. And it's drawn only now. Click. And it's shown only now. So you can see that we clearly have a problem. If only we had a way to somehow profile it. Let's do exactly that. Let's apply the most naive way to profile rendering, console log, to the rescue. Now we have, once again, that 10 by 10 two-dimensional array and a grid. Let's click and see that actually on every click we have 100 vendors. And that might be our problem, right? What is the first thought that you think when you want to optimize some list rendering? And I think, well, React basically tells you what to do. Each child in a list should have a unique key prop. So let's do exactly that. Next commit. And the only thing that changed is that we added that key prop for each row and for each cell. Let's see where it gets us. So we have 100 initial cell renders, which is fine. And on each click, we still have another 100. And now, we have to thank the awesome React DevTools team, because they provide us with the great profiler. When you use that profiler yourself, I strongly recommend you to go to the settings and enable this checkbox to record why each component rendered while profiling. And now let's start the profiling session. Click on that checkbox, stop profiling. So we have a lot of renders. Let's do a rank chart and see why it rendered. So every cell is rendered because props changed, set content. Let's go back to our code and see why is that. We can see that our callback depends on the current state, the field prop, the field variable. So when one cell updates its content, it updates the whole field. And because the callback uses the field from the outer scope, each cell has to re-render because set content is updated. Let's try work around that. So what we have to do is we have to maintain a stable reference to the set content callback. So what happened here? Let's take a look at the cell component first. Now it accepts not only content and set content, it also accepts cell index and row index. And set content now accepts row index, cell index, and the new content as the last prop. We pass all that stuff to the cell component, and the most interesting thing happens with, well, inside of that set cell callback. You can see that we use callback to maintain a stable reference to that callback. So what happens inside? Now you can see that we no longer depend on the field variable from the outer scope because we use a callback signature for updating our state. So what we do here is that we accept row index, cell index, and new content. We pass the callback to the set field. As the first and the only argument of that callback, we receive the previous state, the old field. And for that old field, we do exactly what we did before. So now we don't change our props that we pass to our cell. So it should work, right? Let's go back to our browser. We see that we still have 100 initial cell renders, which is perfectly fine. And now let's click, and we still have another 100 renders for each click. Once again, let's do some profiling. Profile, click, stop profiling. Rank chart. Now our profiler tells us that the parent component re-rendered. When we click on a cell, it calls the setCell callback, which updates the field variable using the callback signature. And because of that field variable is updated, app component re-renders, and it triggers the re-render of each and every cell component. All right, so what other tools do we have at our disposal? Next commit, and of course it's memo, or if we used class components, it would be pure component or should component update, whatever you are most comfortable using. So with memo, if reference for each prop doesn't change, the component is not re-rendered, and probably that's what we want. So let's go back to the browser, click on a cell, and see that each click is exactly one render. We have a single render. Let's profile it, and see that we have exactly one cell rendered, just to make sure that console log doesn't lie to us. Let's increase the size. It's gonna take quite some time. Alright, we have 10,000 cells rendered. Let's click, and it's pretty smooth. And now let's go back to performance and throttle our CPU. 6 times slower. Click, and it's rendered only now. Click. Well, it might be not that obvious. Let's do, say, 130. And again, it's gonna take quite some time. So here we go. Let's throttle my CPU all over again. Click. And it's running only now. Click. And the render takes quite some time. I suggest we head back to the profiler and do another profiling session. So let's do some clicking. So the profiling session result looks kind of weird, right? The cell render itself takes only, well, pretty decent 0.3 milliseconds, blazing fast. But the re-render of the app component takes whole 55.7 milliseconds. So what does eat up our time here? We all know that rendering real DOM trees is expensive, right? And that's where React came in play and introduced a concept of virtual tree, virtual DOM. And virtual DOM, well, we tend to think that it's cheap. However, cheap does not mean free. So what React has to do in this case is, well, basically it still has to go over 10,000 of cells. Well, and in our case it was, what, 16,900 cells and compare their props. This process is called reconciliation. And that's exactly what we see here. The real render takes only 0.3 milliseconds, but the reconciliation of the whole enormous tree that we have here of 16,900 nodes takes other 55 milliseconds. If we cannot lift our state up, maybe we can move it down. So the basic idea is that now we keep our field outside of the react. So react is on one side and our field is it lives outside of react. React doesn't know about that field. React doesn't know when that field updates, how it's being manipulated, and that's the whole idea. So now our app just iterates over that field. It still renders the same cell, and it passes row index and cell index to that cell component. Well, that cell still has to somehow know where exactly in that data grid it lives, right? And that cell, it accepts cell index and row index, and for those indexes, it calls setCell method of that field. So it looks pretty similar to what we had before. And just instead of rendering the content directly, it calls some callback cell content to get that content from that field. And what is the field? The field is our class, which contains the state of our data grid. It accepts its size, and in the constructor, it generates the same two-dimensional array. So cell component just retrieves the data from that array, and setCell is our way to update the data in our two-dimensional array. It resembles our previous setCell callback that we used before. And we also have the map method to iterate conveniently over our field. So let's head back to the browser and see where we are at. Well, we can do some clicking, we even see some console log statements, but we don't see nothing. Yeah, that would be the right and the most polite word to describe it. Why? So, as I said before, now React doesn't know when the field is updated. So React doesn't know when it should re-render. So first, let's take a look at these 4 lines of code. How can we update a component? How can we trigger its re-render? Well, we can obviously use forceRender method of a class component. But that would mean that we would have to rewrite our implementation to class components. And that's not something I'd like to do. What's the alternative for our functional components? What are the other ways to trigger a render of a component? Generally speaking, we can update its props. But if we updated the props of our cell component, that would kind of defeat the purpose of the whole optimization, right? So another way to do it, to go around it, is to update the state of the component. We use useReducer hook. We set the initial state to 0. And when we want to trigger the re-render, we just increment our state by 1. When you want the component to re-render the first time, it's going to be 1. And then when you want to re-render it the second time, the state is going to be incremented to 2, to 3, to 4, and etc. and etc. You get the idea, right? Now, once we have a way to trigger the re-rendering of our cell component, we still somehow have to know when to trigger that re-rendering. And that would mean that we somehow have to subscribe to the updates of the field. So let's add subscribe cell updates method. it accepts row index and cell index, which would be the indices of the component, of the cell component that we want to, which updates we want to listen to. And it accepts onSetCell callback, which is the callback that we're going to call or execute once the content of that cell updates. Now, we have to head back to the setCell method, and after updating the data, we try to find the subscriber in the list of the subscribers that we have internally, and if one found, we call that callback that we found in the list. And last but not least, we also introduce the internal object that stores the list of our callbacks for each cell. And now in our cell component, we use our brand new hook useForceRender, and using useEffect hook, we subscribe to our cell updates. We pass their row index and cell index that we receive from the app component, and we pass the forceRender method, which is our callback that we want to use for that cell, and that is going to trigger the cell update. Let's see where it gets us. We still have 100 initial cell renderers. Click, and it seems to be working. Cool. But before we declare it a win, let's check it on the same setup that we had before. Let's do some clicking, and it seems to be blazing fast. Let's head to the performance section and do some CPU throttling. And still, it's blazing fast. Yay! Seems now we can declare it a win. And just to make sure, let's head to the profiler and do some profiling. Click. And now you can see that we no longer have that expensive reconciliation process of the whole app component. We only do the rendering of that single cell component that we updated. Some closing thoughts and words. Please don't do any premature optimizations. I really mean it, please don't do it. Nothing is free in this world, especially when it comes to software development. For the performance, we have to pay tenfold. We have to pay with complexity. And if you don't really have a very serious need, a very serious case to do any performance optimization, you'll just increase the complexity of your software for nothing. And when you return to that piece of code half a year later, you might end up not knowing what to do and what's going on here. Here are the links to the related article, to the repo with the source code that we saw here. And, well, just want to say, guys, that I'm happy to be here, happy to speak at this amazing conference, happy to feel like a part of the community willing to learn despite all the obstacles. If you want to contact me, just send me a tweet or email. The QR code contains the link to the slides, and long live JavaScript!
you think about Hello, everybody. Welcome to Byteconf React 2020. Today I'm going to present my talk called From Create React App to Create Any App, in which one I'm going to talk about my experience inside my company when we have to move, or when we were expanding in the company, we have this issue of architectural problems and how did we solve it. So, but first, let me introduce myself. Hello there, my name is Emmanuel Suriano, but I like people to call me Emma because it's my nickname. I'm a web developer. I'm also an open source enthusiast. I do a lot of open source. I have my own projects, and I also contribute to a few of them when I have some time free. In my free time, I'm a writer. I have a tech blog when I write about the stuff I do at work, and I try to put it in a post so then I can spread it with the people. I also have a non-tech blog when I write about the stuff I have in my mind. Lately, I've been writing about coronavirus and how it's affected me, for example. Besides that, I love to eat. I love to cook. That's one of my hobbies, for example, during the weekend. And the last thing is I love to travel, but sadly with this current time, it's quite hard to do it. So I hope that you're staying strong at home, and yeah, let's enjoy the conference together. So let me tell you about the company I'm working on. The company is called Omio. Before it was called Go Euro, and it's a travel company, and our main goal is we are there to make travel easy. The way that we do that is we provide a platform in which one you just simply search from where you want to go to where, and then it will automatically search against all the different transportation methods that we have. In this case, you are going to see planes, trains, buses, and in case there is some water in the middle, you can travel by ferry. So in this case, you as a user, you don't care about the routes, you just care about going there from where you are. That's basically our goal. But let's talk about how do we work. So the whole company is structured by business needs. What I mean with this is inside the application, let's say search, which is one of the main parts inside the flow. It's where the user will go to say, okay, I'm going to travel from France to Germany, obviously some cities inside. And then there is going to be a team specialized only to provide a good experience of search for the user. The same applies to booking. In case the user goes to the booking page, there is a team specialized on making sure that the booking experience works. That takes us to the next point, which is we work with something called micro frontend or microservices. And this is great because it allows us to have autonomous teams. And this is not just about, oh yeah, because it's separated and stuff. No, they can actually decide how they want to work inside a team, like which methodology they want to follow, when they want to release. In case they have some crashes, they are the one that they need to solve it, because basically it's like a part of application that you own. And also they can decide on technical decisions in case they want to use one tool or another. But this also comes with some issues on the other side. So one of the biggest ones in the beginning was integrating all the projects together. It's quite problematic, or at least was quite problematic. Given all this flexibility of a wide variety of technologies, when we were putting all the micro frontends together into one huge application, it was quite hard. Most of the time they released and they didn't realize that one part of the application was broken, or maybe the versions of some dependencies were mismatching and there was breaking changes in the middle. So it just wasn't working. Then the other problem is, as all the teams are separate, sometimes they do want to use the same thing, and then they say, oh, okay, that team is using technology X, and say, okay, let me see how you're using it. And they just simply go there, check the implementation, and copy and paste the code into their repository. So that, as we know, is not maintainable, it's not scalable, and it's considered a really bad practice in terms of programming. The third one is there is no way to spread a company-wide stack. When I joined the company around 2 years ago, they told me that our stack was React, and that's true. But then you start to move to different projects, and then some projects are using React with Redux, others React with, I don't know, Apollo, and then you say, okay, what is our stack actually? And if you think about it, it's very, very hard if you don't have like a centralized place across all the teams to say, okay, we're going to use this for state management, we're going to use that for styling, for example. So yeah, that as a newcomer or someone that wants to have an overall picture of the projects, this is quite problematic. And the last one is every team had to deal with the bootstrap by themselves. So given the micro frontend architecture, it's quite normal that you want to create new projects from time to time. And yeah, every team has to deal with that by themselves. Oh, you want to start a new project? Yeah, just do it by your own, you know, like, okay. And how do they do it? They say, oh, I have a working project already, so I will just copy the structure, remove all the specific components or parts that I don't want to in the new one, and that's it. That is my bootstrap. Yeah, it kind of worked, but the main point is we're going back to the second point. We are repeating code and configuration, and then it's just a mess. You end up having like template projects, you know. It's like, oh, I want to boost. Oh yeah, take a look at search project, you know. So yeah, someone had to do something, and that's how my team was born, UI Platform. I'm a member of that team. And our main goal is that we empower teams to build their micro frontends in a unified and efficient way. And the first time when we came up with this definition for our team, we say, okay, so we need something that they can use in order to fix all the previous issues. And they say, okay, what do we use in case, for example, I want to bootstrap a new project, or in case I want to have a centralized place or a place of abstraction? And then we said, oh, create React app. Like, why not? If you think about it, create React app is a very good fit, or at least that's what we thought. But look, you can quickly bootstrap new projects, right? You do create React app, my shiny new project, and then it will create a folder with the CRC, with dependencies installed, everything will be there. So check on that. Easily share across a company. You just need a dependency for that. It's like, okay, yarn or npx in case you want to call it without a dependency, and that's it. That's how you share it. The third one is keeps all the technologies and configuration centralized. And this is the case in Create React App, that it abstracts you from Webpack, for example. In case you don't know, but Create React App is running Webpack inside with tons of different plugins. You have Babel. I think there is a lint configuration when you run a start. So it abstracts everything, and you don't need to care about which technology they're running. You just simply use it, and it works. It's great. It's a very good experience. And the last one, it provides a set of scripts that client can run. This is okay for start and build. So in the case of Create React App, also if you want, you can inject, but we were trying to avoid that. That was the main point of the framework. And yeah, those two commands are really helpful. But I have to be honest with you, when we actually tried it. We say, okay, let's give it a try. Let's try to adapt some of our projects into Create React App stack. We actually took a look into other technologies that they try to customize Create React app, like Create Rewire app. And then we actually thought about the idea of ejecting and then kind of encapsulating everything. But I think there was a problem with not the way it works, but the way that the stuff that they have inside. So the problem was the stack. The stack was not the same as we have. And we were just trying to make it fit for ourselves for some weird reason. So if I have to picture it to you, it was something similar to this. We were trying to push ourselves in order to use this technology that, to be honest, it wasn't the fit for us. So yeah, we ended up discarding the whole idea, but we like to see that the whole process wasn't a waste of time, because it was a learning process. Now we knew exactly what we wanted to create or to build. So after that, we identified some framework principles that we wanted to build in this new one. So the first one is we want to have one dependency. We think that having one dependency is great, as we saw before. To share across the dependency is easy, it's transparent, no problem. The first way to bootstrap your project, we wanted something very, very similar, like something that you can execute in the CLI, and boom, you have your project right there with the dependencies installed, everything available for you. The third one is one place for all technologies and configurations. And in this case, we want to use our technologies and our configuration. So let's say that we are using a storybook, for example. We want to use a specific version of a storybook and the add-ons that we really care. And in case we want to create custom add-ons for our needs, we should have it inside. So that was our main goal. So by accomplishing this, clients, they don't need to care about the version that we are using or which add-on, or the idea was to basically simplify the repetition that we used to have and the misconfiguration. And the last one is to keep the scripts to cover the needs of a team. And Create React App does it in a way, but just cover development and kind of release, if you think about it. But when you're working in a team, you normally need more than just that. So for example, you need to think about, well, bootstrapping, that's the second point. You need to think about testing. Like Create React App doesn't care about testing. Now, I'm not saying that it should, but our framework inside the company, it should, because we're encouraging people to test. I don't know, environment setup, for example, in case you need to have something to work and you need to have it installed on your computer. Well, we should provide that for people. So we created, and we call it FS scripts. So the name basically means front-end scripts, because it was mainly focused for micro front-end. And let's recap what we done. So one dependency, that was pretty easy. Yarn add, and then the name of the dependency under the label of the company. Then a fast way to bootstrap your project, we are using npx. So we will download the package from our npm and then call the init script. This will create a folder inside the developer computer. Then one place for all the configurations. So this is our current stack. I'm going to briefly introduce it. So most of our projects are cross-platform. We are using React for web and React Native for Android and iOS applications. Then we standardize project to use TypeScript. So now most of our projects, the new ones, are statically type. Then we're using style components to style our components, and this has a reason. The good thing about style components, it gives you the same API to style React and React Native. So it creates a seamless integration, or at least it's something similar for developers that never work with React Native. Otherwise, you need to use a style sheet for that. And then we're using Jest for unit tests and integration tests, Cypress for end-to-end in the case for web. Storybook is our main development tool. because it goes really well with micro frontends. You can put your small piece of code or a small page and send different parameters, and then you can play with it inside. So we're using that for web and for React Native, both. Then ESLint, and in this case, we're using some specific plugins and customizing it. So we kind of create a ESLint configuration for the company. And this is very cool because back in the time when we didn't have this tool, everything was using their own ESLint rules. And when you're working with micro frontends, you normally need to switch from project to project. And if every project has a different ESLint configuration, it's very annoying, like very annoying. So in this case, we're not enforcing people to use it, but we're giving the chance to use it and to extend it. That's our idea, that in case people don't like some specific rule, they can turn it off, but more or less we should be aligned. Then the last two, we are using react.js for internalization and semantic release to have versioning in case of releases. Then a script to cover the needs of a team. So here we identify 5, let's say, parts across the development process or when you are working in a project. So the first one is creation. So for creation, I already talked about it, is this script to init that can bootstrap a new project. It's quite straightforward. You call it, and then you have the folder with your dependencies. Then development. So in this case, this script go and has already the configuration for Storybook Web set up for you, and you can run the different scripts of start and build script, always from the command line. Then Storybook run, the same as before, but in this case for React Native. And the main difference is in React Native, there is no way to build. Or at least we are not using it yet, and we are just providing the start script, and in which one you're going to see it on the phone, how it looks after. Integration React Native. So this has been a huge accomplishment that we built for the teams, because as we are working with micro frontend, and you can see also this pain point in Web 2. It's quite hard to see how your micro frontend integrates in the whole application. There are some solutions on the website, but we didn't integrate it in the tool yet. We can do it, and we plan to do it soon. But we started with React Native. So in this case, your micro frontend is going to be integrated along with the other ones to create a big bundle, which then you can play around in the real applications. So you can think of the preview functionality of some websites. Every time you create a PR, you have a link that you can preview how the page function or behaves with your code. So this is the same, but locally. And it really allows team to check stuff before releasing them or deploying it. Then we have lint that will run ESLint with the company configuration. As I said before, they can extend it. And then update translations. This is the case for React.js. All the projects, they rely on specific translation keys. And in case they want to get the latest one, they can simply use this script. Then testing. So we have a script of test. In this case, we are loading and configuring Jest, and we can run integration or unit tests for web and for React Native, which is great. Then end-to-end web, configuration of Cypress with some helpful commands, and which is already there for clients to use it. And yeah, Cypress will allow clients to run end-to-end tests for web. And the last one is visual testing. And this one will run static snapshot testing, like visually, of the storybook stories for web. And this is something that is great, and people have been really, really glad that we made it. Because when you think from the developers side, they don't need to do anything. They were already using storybook stories in order to develop. So in this case, you run this script, and the first time is going to generate a screenshot of your story, and then the second time you run it, it will regenerate it and compare with the previous one. So this is great in case you made some changes in CSS and your component changed in a way. Then in the terminal you will see, hey, this image they don't match. So can you please take a look? And then you can say, oh yeah, I intentionally made this change, or no, I think I fucked up, so I just need to revert the change and then avoid committing code that I don't want to push. Then we have environment setup. So for most teams, for many people, this might be, okay, you just run yarn and you install your dependencies and that's it. But for us, as we have a cross-platform team, this is needed. Like, they need to have the possibility to download their Android application or iOS application and start the emulator. Before, developers had to go to the respective Android Studio or Xcode, build a project and run it locally. And this gave us a huge advantage in terms of speed development, because they don't need to deal with the build step. For many of you, the build step of Android and iOS can take a lot. So yeah. Then we have deployment, which is the last part. And for deployment, we are providing a build script. In this case, we are transpiling the project using TypeScript. And then deploy CI, which is going to deploy your project using semantic release, which reads your commits. And given your commits, it decides which version is going to create, if it's going to be a patch, a minor, or a major. So now it's time for some demo. So here I have a project which I already created before, as you can see. And inside the project, we have some modules. We have some scripts inside package.json that we can execute. So let's start with the first one. Let's start with the storybook. So startware, as I say, is going to start a storybook script, and in this case, we're going to read the stories that are that by default, when you init a project, they're already created for you. So let's wait a little bit. Cool. So this is the address. Copy and we paste it. So this is how it looks, the storybook by default. As you can see here, we are already using the component library of the company. And then also we made some things for the user.